Hello and welcome to this session about full stack web development interview questions and answers by Intellipaat. In today's digital era, with almost every business from local shops to gigantic MNCs adopting online platforms, the demand for full stack developers is skyrocketing. Even if you were to go on Google right now and search for full stack developer jobs, you'll end up with over 11,000 plus job opportunities along with an average salary of over 8 lakhs per annum. To help you land one of these jobs, our panel of experts in the field did a thorough market analysis to find out exactly what the companies are on the lookout for. And after consulting various industry experts associated with us and studying thousands of interviews of our learners, we were able to pinpoint the topics that were being asked repetitively. In this particular video, we've broken down these topics into 5 key segments. We'll start things off with the fundamentals of JavaScript, which will help you lay a strong foundation for the topics ahead. Next, we'll look into React.js, followed closely by Node.js and Express.js. Finally, we'll wrap up this session with MongoDB. So, in a nutshell, if you watch this video till the end, I can assure you that you'll have enough understanding of the basic requirement to start applying for entry-level full-stack developer positions or even freelance. On that note, let's start with our very first module. So let's start with our first module, that is basics of full stack web development. Now in this particular module, we'll be covering 15 questions and those will just be the basics that you need to know before starting with the main part, that is the MERN stack part. So starting with the first question, that is, what do you mean by hoisting in JavaScript? Now this question is so common and so important that I think if JavaScript is included in any particular interview, there is a 85 to 90% chance that you will be asked this question at least once. So, in technical terms, hoisting in JavaScript refers to the behavior where a declared variable or a function is hoisted to the top of the scope in which they exist during the compile phase. Now, JavaScript has this behavior. JavaScript has a lot of weird behaviors. Now, this is one of those behaviors in which a variable, when it is declared, not initialized, just declared, it is hoisted to the top of the scope where it is existing. To understand this better, I think we should look at an analogy. So let's do that. Consider this tree as your existing scope, this little boy as your JavaScript, and this ball as your variable or a function. Now, what happens is when you compile your code, that is when you run your code, JavaScript throws this ball to the top of your scope. That is, it hoists the variable to the top of whichever function it is existing. Now, there are 3 types of hoisting in JavaScript. That is variable hoisting, function hoisting, and let and const hoisting. Starting with variable hoisting. Variable hoisting is where only the declarations are hoisted and not their initializations. Now, declaring a variable and initializing a variable are 2 different things. When you say that, okay, I want a variable X, that is declaration. But initialization is if you provide some value to that X. If you say, okay, X, hold the value 5, then that is initialization. You're using the variable. Not just like X is there. When you assign it a variable, it is initialization. There's an example. Okay. Now let's move on to my code editor where I'm going to initialize a variable. Right now, declared it. Variable X exists. This is declaration. And now if I assign it a variable, this is initialization. Now let's try to call this variable, console.log, value of X. Okay. Now if I try to run this, you can see by this line there is no X. X is declared at this particular point on line number 3. So if you try to run it, you will see that the variable is undefined. That is, we haven't provided a value till this point. So if I bring this down and then run it, then it will have its value. Moving on, we have function hoisting. Function declarations are fully hoisted, meaning you can call a function even before you define it in a code. Okay, now let's try to run this as well. I am going to write down a function. Here, my function will be known as greet, which will say, hey, I've been called. So hi. Now I'm going to call this function here. Keep in mind that it has not yet been declared if you consider this particular part. So if I try to run this, it is able to access the function even though it is not declared here. That is function hoisting. Let me clear that. And let's move on to the next part. Let and const hoisting. Now here the same problem comes in that I told you before, that variables are declared with let and const are also hoisted, but they're not initialized. You cannot access these variables. Let's take an example here for better understanding. If I declare a variable let x is equals to 10, and if I try to access it from here, it will tell you that cannot access x before initialization, because it is a let variable, and even if you try to do it with const, you will get the same result. Cannot access y before initialization. Now this happens because again the value has been declared but it has not been initialized. So in case of let and const, they won't even let you access the variable to begin with. So by the time they access, these variables are in a temporal dead zone. That's a particular term we use in JavaScript. So to understand this better, you can take an example of maybe say a Zomato guy who is there to deliver your order. Now Zomato guys, they are like filled in a room right now and they're just standing there. If you don't give them any orders, they will not come out of the room. They'll just stand there. That's called as a temporal dead zone. This particular room is called as a temporal dead zone. So your variables exist in that room, in that temporal dead zone, until you have given them value. So I hope that was enough to clear hoisting. Now let's move on to our next question, which is, what is the difference between local storage and session storage? Let's look at the technical definition first for local storage. For local storage, data that is stored has no expiration time. It remains available even after the browser or the tab is closed and will persist until it is explicitly deleted by the user or through the code. Let's take an example for this also. Open a new window or a new tab and open the developer tools. Now let's start with local storage dot set item. I'll give the value as Arya. Okay. Now if I try to access this local storage dot get item, that will be my name. Arya is there. Let's do the same for session storage as well. Session storage dot set item, my name is Arya. Let's try to access that as well. Session storage. This is fine. We are able to access in both local and session storage. Now, if I open a new tab, open my developer tools here as well. If I try to run the same code with local storage, I'll still get my name. But if I try to do this with session storage, the value does not exist. That is the difference. With local storage, the data is permanent. However, in case of session storage, the data is temporary. It can only exist within a particular tab. That is in the first tab, the session storage, if I try to call it again, it will still be there. But if I switch tabs, it's not there. Local storage, permanent. Session storage, temporary, only exist in particular tabs. Now let's look at the proper definitions. So, data stored in local storage has no expiration time. It remains available even after the browser or tab is closed, and it will persist until it is explicitly deleted by the user or through any code. The best example you can consider for local storage is Amazon. If you have logged into your Amazon account and if you click on this add to cart button, then it remains there. It's not like you just log out and then you log in back again and your cart is suddenly empty. It will still be there until you remove it from your cart. Next, you have session storage. Data stored in session storage is tied to the specific session of the browser. It gets cleared when the browser tab is closed, meaning the data is only available as long as the tab or the window is open. Best example you can consider is in LinkedIn. So you must have applied for jobs on LinkedIn. So there's this particular interface you can get in LinkedIn. And if you, while filling the form, if you reload it, then the whole data that you must have filled before just disappears. That is session storage. So if you look at it in a tabular form, data persistence, for local storage, it persists until explicitly deleted. Session storage, cleared when the tab is closed. Scope, local storage can be shared across tabs of the same origin. Session storage, unique to each tab or window. Use case, local storage is for long-term uses and session storage is temporary. Moving on to our next question, which is how can page loading time be reduced? Page loading time is very important to increase your user retention rates in your websites. So there are certain ways you can optimize page loading times. The first one is optimizing the images. You can use formats, instead of using formats like your JPG or your PNG, you can use WebP formats, which offers smaller sizes but with good quality itself. Next, you can minimize the HTTP requests. You can put your CSS and JavaScript in the same file itself so that the number of HTTP requests your website has to make is reduced. Next, you can enable browser caching. I hope you're familiar with the concept of caching. That is when if you visited a website once, then the data is fetched from the original server only once. Next time when you access the same website, that whatever was loaded the first time, it's stored in your local machine. So that the next time you're opening the website, it doesn't have to load from the start. It can store some images and videos in the local machine itself, reducing the page loading time. Next, you have CDNs. CDNs, I'm sure all of us must have heard of. A lot of companies like Amazon, Prime Video, all of them use it. It's like taking the data from the server that is closer to you. Like if I'm right now in India, so a server from Mumbai will be much more closer to me instead of a server from England. So moving on, you have lazy loading, which is delaying the loading of images and videos until they are needed. A very good example of this you can find in Pinterest. Let's explore. Okay, I like reading. Now, if you try to scroll down, you can see that half of them are loading when I am getting there. Before that, it's not loading. So that is the concept of lazy loading. Only loading the particular parts when you reach there, when the particular interface is active in front of the user. Moving on. What is the difference between SOAP and REST? Let's look at the differences in a tabular form first. SOAP, what it is, it's a strict set of rules for sending messages. REST is a way to use existing web rules to get data. SOAP uses an XML format, which is really complicated. I'll show you the code in a minute. Just bear with me. Just look at the differences. Then we'll see the code and you'll have a better understanding. REST uses JSON, which is way more simpler. Connection type, it is stateful. Stateful meaning it can remember the past requests or not. REST doesn't remember the past request at all. How it works, SOAP has its own set of rules for sending messages and receiving, but REST uses standard methods like get and post, which makes it far more easier. Now let's look at the examples I have here. Here I have Postman. I'll leave the link to my GitHub in the description down below. You can find all of these code in my GitHub account. This is my SOAP URL right here, and I'm making a post request with this particular body. This is how it looks. Right now we're using this API to convert this number. And for that, we require all of this. We're just sending the data. And for that, we need to write all of this heavy code just to convert this to word, to number. Now, if I send this data, I'll get the response something like this with 123. Next, moving on to REST URL. That's a GET request. Let's try to send it. And here I have. Now, if I try to make a post request with the body, I'll copy that real quick. If I put it here, it is created. Now you can see that just for creating a new post, this is all the code I required, and that too I copied from the previous, whatever they'd send it, I taken that code from here and pasted it here and then just modified my data. But for SOAP, you can see how complicated it is just to make one particular post request. Okay. So in a nutshell, the major difference between SOAP and REST is that SOAP is a protocol with strict standards and advanced features, making it suitable for complex, secure applications because it has its own set of rules, so it's harder to modify it. While REST is an architectural style that is simpler and more flexible, making it deal with web services that require speed and scalability. Moving on to our next question. How is GraphQL different from REST? So if you try to compare these three in terms of the ease of use, GraphQL, REST, and SOAP, the order will be something like SOAP will be at the bottom because it's really difficult to use. Next you have REST, it's better than SOAP, and then GraphQL, which is even better than REST. Okay, so let's look at an example for better understanding. So now if I try to make a post request, I need to specify a body here. I'll just put this here. Now if I try to fetch the data, I'll get a list of every single country. Now I don't want every single country, I only need a specific country. Now if I only want a particular country, say this one, AD, then I can send the request and I can modify the query in such a way and then send the request and I'll only get a single country. Now if you notice, I'm only getting the parameter that I asked for. If I add code here as well, I will get the code too, but I'm only getting the result I'm asking for. Now, if I go to REST API here, let's make a GET request. If I send it now, in the parameter section, if I only want the post with the ID 1, I get the post with ID 1. But you can see that a lot of other things like the user ID, the title, the body, everything. I'm getting all of this as well, additionally as well. This is called as overfetching, when you get all the data about a particular resource. Even if you don't want every single detail about a particular product, you'll still get it. That is the difference between REST and GraphQL. In Graph, you can specify your whatever resource you're getting, you can specify it in the server itself while sending the request itself, so that whatever is being fetched is what you need from the server. But in case of REST API, everything is fetched, and once you get the data, that is when you filter, oh okay, I only need this particular part. So moving on, let's look at this in a tabular format for better understanding. So we have data fetching. There's a single endpoint for all the queries. In REST, there are multiple endpoints for different queries. Response structure, client defines the structure of the response. I can define whatever I want. REST, the server defines the structure. The server will just give you, if you'll ask for a particular resource, I want the post with the ID 1. Even if you request for a name, the server will just send you everything related to that. Its name, its description, its author, its title, everything. Next, overfetching, underfetching. GraphQL reduces overfetching and underfetching by only delivering you what you need. REST often leads to overfetching or underfetching. Let's look at some more examples. You had multiple endpoints in the API that we used. We can use post, we can use users, you can use post as a post request. Clients often need to make multiple requests to different endpoints to gather all the necessary data. Single endpoint, clients can request all necessary data in a single request, avoiding the need to hit multiple endpoints. Next, you have a fixed structure in REST, but in GraphQL, it is much more flexible because you yourself can request for the fields that you need. So it is flexible. So in a nutshell, while both GraphQL and a typical REST API can achieve similar end results, their approaches differ significantly. In REST APIs like JSON placeholder, you fetch data from a specific endpoint and perform filtering on the client side, that is after fetching the data after it reaches my laptop. While in GraphQL, you can tailor your queries to retrieve only the necessary data from the server itself. Moving on to our next question. What are the components of a CSS box model? Alright, so if you go to any particular website and you open the developer tools, the CSS box model is always there. If you go to the layout, the computed, there it is. This particular box that you can see with margin, border, padding, and the main content of the website is called as the CSS box model. Now for a better understanding, I have a code. So let's try to run this code. There's the margin, then the padding that's inside, the border. Let's look at it a bit more closely. See, the margin, the border, the padding, and the content inside. Now if you go to the styles part, you can see the width. If I increase this, you can see that the box is expanding horizontally. That is the width. And that is because I've set it in the left side of the website. If it was in the center, it will expand from both the sides. Next, you have the border. If I try to expand this, you can see the green color is expanding. That is the border. Padding is the inside part. So if I increase the padding, the main content is not expanding. That particular space remains the same. But the space between the border and the main content is expanding. That is called as padding. Alright, that's all you need to know about CSS box model. Now let's look at it from a technical perspective. First, you have the content. This is the actual content of the box, such as text, images, or any other media. The size of the content area can be controlled using properties like width and height, which I told you before. Padding is the space between the content and the border. The padding adds space inside the element, effectively increasing its size without affecting the actual content. You can control the padding using the padding property. Next, you have the border. The border surrounds the padding, if any, and the content. It can be styled with various widths, colors, and styles. The border's dimensions can be controlled using properties like border width, border style, and border color. Next, you have the margin, which is the final one. This is a space outside the border that creates space between the element and its neighboring element, which separates one particular element from another. If I have a button here and another button here, the distance between them is the margin. Margins do not affect the size of the element itself but create a space around it. You can set margins using the margin property. Moving on, what is the difference between a class selector and an ID selector in CSS? Now let's look at a code for better understanding. I'll have to create one here. Let's create the style as well. I'll call my main boxes. That is the ID. Inside of this, I'll put a class as the class box. Main box with ID selector. Internal box with class selector. Okay. Let's run this code now. We have a main box and an internal box. Now let's try to style them. The ID is main box. Let's put its background color as light blue. ID. And the class box's background color is say pink. Okay. Now the main difference here is that the ID can only be used once, but class selectors I can use it multiple times. If I call this class selector 1, I can make it as many times as I want it to be. And every single time, the same styling property will be applied to all the 3 div tabs. If I were to specify a border, but with IDs, I cannot do that. ID can only be applied to one particular thing. So now let's just look at the differences. Can be applied to multiple elements. You can use the same class on different HTML elements. It has lower specificity than ID selectors. And for ID selector, each ID should be assigned only once to the element and has a higher specificity than class selectors. By specificity, it's trying to say that if your element has an ID, it is more likely to latch on to that particular ID because it is unique. But class selectors, when you have a huge HTML or CSS file, sometimes it can get confused, and sometimes because class selectors you can assign it to multiple elements, it might get clustered and it might get all messed up together. Moving on to our next question. What are the various data types present in JavaScript? Now in JavaScript, there are basically 2 main types of data, that is the primitive and the non-primitive. Primitive data types are immutable, that is their value cannot be changed, and non-primitive are mutable, that is their value can be changed. Now inside primitive, we have 7 data types, starting with the number. Number represents both integer and float points, like 5, 3.14, -10, etc. Next, you have big integer, used to represent numbers that are larger than the number data type, created by adding an n to the end of an integer. You can see in this example, there's an n. It represents the big int. Next, you have string. String can be double, it can be single, or it can be with backticks like this, hello world and hello world. Next, you have Boolean. Boolean can either be true or false. It represents logical values. Next, you have undefined, which is assigned to a variable which is declared but not initialized. We saw it in the first example, in the first question, in the hoisting question as well, when our variable x was defined, var x was defined, but when we tried to access it, it showed its value as undefined. That means the variable is declared in the code, but it's not been assigned a value yet. Next, you have null. Now, to avoid the previous problem, we just assign it the variable value null. When we don't know what value to give, you can just give it a value, which is null. Represents an intentional absence of any object value. If you don't know, or if you, at this point, if you don't want to assign any value to your variable, but not want to show it as undefined, then you can just assign it with null. Next, you have symbol, which represents a unique and immutable value, often used as object keys. Symbols are useful for adding properties to objects that you want to keep hidden or private. Now, let's look at the examples over here. Integer, you declare it like this. Let age temp or a number or a floating point number. Big int is when you add a n, if you write any long number and add an n to the end and add an n in its end, that's called as a big int. Next, you have strings, which is double quoted strings, single quoted strings, or backticks. Next, you have Boolean values, which is logical value, true or false. Next, this is undefined. We have seen this already. This will show as undefined because it's also not assigned yet. Null values, symbol. An interesting thing about symbols right here is, although both of these are the same with their descriptions being the same, but if you try to run this particular code, your output will be false. That is the interesting part about symbols. Moving on, we have non-primitive. Non-primitive, we just have one particular subset, that is your object. It represents a collection of key value pairs, can be used to store various data and complex structures. This is like your JSON format. So an example here is, if you define an object called as person, you can specify its name as Arya and its gender as female, or any other category. If you want to specify the, say, if I call it as favorite hobby, I can put reading there. That's how objects work. Moving on to our next question. What is DOM? DOM, or Document Object Model, is a programming interface for web documents. Now, it represents the structure of a web page as a tree model, where each element in the HTML or XML document is a node in the tree. Through the DOM, programming languages like JavaScript can interact with and modify the content structure and style of a web page dynamically. So if in any particular website, this is how the DOM looks like. A main document is there, followed by an HTML head title. Then there is a DOM example, that was my title. Then there's a body with the h1, which is hello world. Inside the body, I have an h1, which contains this particular string as hello world. Then I have a paragraph tag, which has this particular paragraph tag. Then I have ul, inside of which I have 3 list items, item 1, item 2, and item 3. That is DOM, which specifies it in a tree structure. The document is the root of the DOM tree, representing the entire web page. HTML element is the parent node containing 2 main children, head and body. HTML, head, body. Inside head, you have a title node with the text DOM example. And inside the body, you have multiple children's. So, document we discussed, the entire web page is represented as a document. Node is each element, like the div, the p tag, the image tag is a node. And the tree structure is, these nodes form a hierarchical structure with parent and child relationships similar to the family tree. Moving on, we have, what is the this keyword in JavaScript? Again, another very important question. In JavaScript, the this keyword refers to the current execution context or the object that is currently executing the code. Its value can vary depending on how a function is called. The best way to understand this is with an example. Say you have a particular code here with the button. That is, if you see when you're adding an event listener to this particular button, a click event listener, look at how we're calling onto the button. Whenever it's being clicked, you're logging that button into the console. But if you bring this keyword into the picture, instead of putting the button there, you can directly put to this. That is, this particular this here, this is going to be confusing. This is referring to this button. That is, it's referring to itself. This keyword is used inside the function to refer to the calling function itself. It can be used in multiple contexts. It can be used in a global context where this function, in this particular example, this function is calling itself. So that's why we are putting this keyword here. Next, you have a function context where you're calling to the object itself with this keyword. Or you have an arrow function where again this object is being called with this function. And you can even use this inside event handlers, as we already saw, and constructor functions. I repeat, this is very commonly used inside constructor functions. Moving on, we have our 11th question. What are the advantages of using a CDN? Now, obviously, using a CDN has a lot of advantages. That's why a lot of popular and famous companies use them as well. There are a lot of advantages, so let's look at them one by one. Starting with improved load times. Say if I'm in Bangalore right now, then a server which is inside Karnataka itself will be closer to me than a server which is in Delhi. So that is why my load timing, the time it takes for my website to load, will be far better if my server takes the content from a server inside Karnataka itself. Next, you have increased reliability. That is, if one of the servers inside Karnataka fails, then there will be multiple servers inside one particular state itself. So even if one server fails, there will be multiple backup servers. Hence, the reliability for the users to fetch the data will be increased significantly. Next, you have a reduced bandwidth cost. Now, obviously, transferring the data also costs a lot of money. But if the distance is reduced, as in the cost for fetching the data from Delhi, or say, and the cost of fetching the data from Maharashtra, if I'm in Karnataka, will be different. And the time when I'm fetching it from Maharashtra will be far lesser than from when I'm fetching it from Delhi. Moving on, we have scalability. Now, this can handle large amounts of data. This also acts as a load balancer because there are so many servers. If one server is busy, it can distribute the load, the traffic in a way which is best for the user, and it can also increase the health of the servers significantly. Moving on, we have enhanced security. Now, CDN itself provides DDoS protection and web firewalls to secure your websites. Next, you have SEO benefits. Now, obviously, if your website's loading time is lesser, people are much more likely to interact with your websites, which means your website can get a better ranking, a better search engine optimization. Next, you have content caching, which we already talked about, for which we use cookies and all. So content caching is when our secondary server, that's a CDN server, accesses the data from the first time. But the next time, because it has already accessed the data the first time, it doesn't have to keep on fetching, going back and forth every single time. Deliver static content with content caching. You can deliver static content quickly without always needing to retrieve them from the origin server. That is, if my user from Karnataka accesses a website once and the origin server is Delhi, obviously the first time the data has to be fetched from Delhi's server. But the next time when the user accesses the same website, the Karnataka server had already fetched it once in the beginning. So now it doesn't need to fetch it again. So some of the static content, like the images or the videos, will already be stored in Karnataka's server. Hence, the loading time can be reduced. Last but not the least, you have geographic distribution. Now, this is again obviously based on your location. Like you can take Netflix's example. Like if I'm trying to watch a movie, then Netflix can provide me a server. Right now I'm in India. So Netflix can provide a particular server which is closest to my particular location so that I can watch the movie seamlessly. Moving on to our next question. What is the difference between event bubbling and capturing in JavaScript? Now, this is a very important and very interesting topic. The basic difference is in event capturing, the event starts from the top. We discussed the DOM structure in which we had the HTML head, body, then the children of that. So in event capturing, it starts from the body, then the div tag, then the h1, which is inside the div tag. And in bubbling, the order is reversed. Div tag, h1, then the body. For a better understanding, let's look for an example in the form of an analogy for both event capturing and event bubbling. Starting with event capturing. Say you have a company. So in the company, you have the CEO, the manager, and the employees, which are working under the manager. So say if there's a new product feature to be added to a product, that is, the CEO has an idea to add this new product feature to the product, that CEO first communicates this particular feature to the manager, and the manager further communicates this to the employees. That is event capturing. That is body div h1, from the top to the bottom. As for the case of event bubbling, say there are some concerns about this product feature among the employees working in the company. Now these concerns which are generated from the employees is communicated to the manager, and the manager further communicates it to the CEO. That is bottom to top. That is event bubbling. Let's understand this. Now this was an analogy. Now let's understand this with the real HTML code. Here is my HTML code. Here you can see there's a child, a parent, and a box. So the box is the first div which starts here and ends here. Inside of it, we have this child and parent, and then inside of parent, we have child. So it's basically box that comes first, followed by parent, followed by child. Now let's run this particular code. So now event bubbling is starting from the inside and going to the outside and going outside. Right now, this is event bubbling that is going to happen. If I click the box has been clicked. If I click on parent has been clicked and box has been clicked. So you can see that the inner element is clicked first, then the outer element is coming. If I click on child, the inner element child is coming first, then parent comes, then box comes. To understand this better, this was event bubbling. Now let's do it for event capturing. For capturing, we'll add true here. Now this true here with the event handler signifies that you're going to capture the event true. If you don't mention anything, it's by default false and it won't capture the event. But right now we're capturing it. That's why we put true there. Now, if I click on child, initially when we didn't add the true here, when we used to click on child used to come first, then parent, then box. That is bottom to top. But the moment I add the true here, if I click on child now, box comes first, then parent, then child. Top to bottom, it has changed. That is event capturing. And the bottom to top, event bubbling. I hope this example was enough to clarify the difference. Moving on, the main difference is that in event capturing, it allows the parent to respond to the click before the parent. As in when we did event capturing, our box was being clicked first, followed by parent, followed by child. That is, event capturing allows the parent to respond first before the child. In event bubbling, the event bubbling allows the child to respond first before the parent. That is, the child responded first, then came parent, then came box. Moving on to our next question, which is what is use strict in JavaScript? Now, use strict enforces stricter parsing and error handling in the JavaScript code, helping to catch common mistakes, prevent certain action that could lead to bugs, and make the code more predictable and easier to maintain. Use strict is basically used in JavaScript to prevent any bugs which might not be detected at an early stage, but when you go into the later parts of the code development or deployment, that is when you see that there are certain bugs which led to certain errors. So to avoid these minute errors, you use strict. Let's take an example so that you can understand better. Say if we already know about the concept of hoisting in JavaScript, right? So let's take an example of hoisting only. If I had the same function greet, but instead of greet with var, I'll put a variable here. I'm not declaring this variable, I'm directly initializing it, x, I've initialized it. Now I'll try to print the value of this. I'll just print x. Alright. Now if I call this function and if I run this code, the value of x is getting printed as 10. However, if I put use strict here and then try to run this code, it will throw an error. X is not defined. Now this was a very minute change that you might not notice because it didn't even throw an error in the beginning. Without using useStrict, it didn't throw an error. So you will not notice it. But then in the later part of your code, the X becomes a global variable. Although it's defined within this function, X has become a global variable. How? If I try to access the value of X here without useStrict, I'm still able to access X. See, although it's defined inside this, I should not be able to access X outside, but because I haven't officially declared it, X became a global variable, I'm able to access it outside as well. Hence, we are using useStrict, which will prevent this from happening by throwing an error. All right, I hope that was enough. Moving on to the next question. What is the difference between cookies and local storage? Cookies and local storage. Cookies is again temporary and local storage is permanent. One of the main differences between cookies and local storage is cookies is usually used to analyze and track user behavior in a particular website, while local storage is more like storing your permanent data. There are a lot of examples I can give you. Primarily used for session management, personalization, and tracking user behavior. We already know what session management is. Next is local storage, used to store larger amounts of data on the client side for web applications. Now, when you log into a website like Gmail, a cookie is created to remember your login session. In email apps like Gmail, there's a particular session that is created. So you'll see that if you open Gmail app and leave for a while, and then when you come back, it might have logged you out. That is keeping track of your session. So cookies can be used for session management. Then websites like Amazon use cookies to modify your searches. If I am looking to buy a pant on Amazon's website and I browsed for a couple of pants, then Amazon tracks this behavior with the help of cookies so that I will get more recommendations of pants to analyze my user behavior. Next, websites often use cookies to track user behavior for analytics as well. Like Google Analytics tracks your however you're interacting with Google Chrome, Google tracks that also. So that Google can also, according to your user preference, what kind of articles you're reading, what kind of websites you're going on, how long do you stay in a particular website. All of this, Google keeps track of all of this using cookies. Next, we have local storage, which is the best example will be your online games or your offline games also. They save your progress, scores, and settings so that when you return to the game later, you can pick up from where you left it. That is the main difference. Moving on to our last question of basics of full stack web development. How can you prevent a bot from scraping your publicly accessible API? Now, what this means is your API must have had tons of data. Like we use the JSON placeholder API. We saw how there was so much of data inside that. Now, sometimes hackers prepare some kind of bots which can leak this data, which can steal this data from your API. This question is asking you, how can you prevent a bot from accessing your API, accessing your data, which is kept inside the API? There are multiple things you can do. And obviously, none of these are foolproof methods. It still happens a lot. But there are a lot of preventive measures that you can take to protect your API. One such method is API rate limiting. If a particular server is requesting data, fetching data, we fetched data using Postman, that was fetching the get and post method. So if a particular website is trying to fetch data from your API, you can limit it. If you will have to detect it in your website itself. If a website is trying to access your API a lot of times, maybe n number of times in an hour, which is a lot, then you can try to restrict it. You can put a rate limit that, okay, now your maximum amount of trying to fetch the data has reached. Now you can't access it. Now the reason why API rate limiting is so important is, consider if you have a house, right, and you invite some people over for partying. You kept an open invitation that I'm throwing a party and anyone can come in. So there is a possibility that your house might be overcrowded and then you might not be able to keep all those people inside your house because it's overcrowded and overstuffed, and then people won't be able to properly enjoy the party at all. So you will keep a bouncer who will make sure that only the people with the invitations are able to get in. Hence, your resources will be properly utilized inside your house. That is how API rate limiting works. Moving on, we have CAPTCHA integration. CAPTCHA stands for Completely Automated Public Turing Test to tell computers and humans apart. It verifies whether you're a real person or not. I'm sure you must have solved a lot of CAPTCHA when you're trying to access websites and all. Now, this is important. CAPTCHAs are very important because CAPTCHA is like a guard which can differentiate between a human and a bot with the help of a puzzle. Now, humans will obviously be able to solve the puzzles, but bots are not that capable. Once I read an article about Google as well, that when you're trying to solve a CAPTCHA on Google, it's not about clicking the right thing. It's about your mouse movements. Because if I'm a human, my mouse will not go like this. That was tilted. Like this. But if it's a robot, obviously its movements will be very controlled. Move y-axis, x-axis. Your website can track the mouse movements to differentiate between a robot and a human. Moving on, we have creating honeypots. Now, honeypots is like creating a trap for your website. This is actually quite interesting. In your website, you can create some elements which are invisible. You can decrease their transparency to 0, their opacity to 0, so that to the human eyes, it's not visible. So how can you interact with an element if you can't see it? But bots who are visiting your website, they don't know what's visible and what's not. So they will interact with this hidden element. That is creating honeypots, creating obstacles or creating hidden elements that humans will not be able to see, but bots will, hence blowing their identity. Moving on, we have obfuscating API endpoints. Obfuscation means making your API endpoints less obvious or harder to find out. That is, instead of giving an API endpoint like API/getData, you can put something much more complicated. Next, we have anomaly detection. That is spotting anything that looks unusual or suspicious, like a sudden spike in requests that is similar to your API rate limiting. Moving on to our next module, that is React. In this particular module, we'll be covering 10 questions about React, from basics to advanced. So let's start with our first question. Explain virtual DOM and how it works. So in React, to reduce the number of renders, we have virtual DOM. Now, virtual DOM is basically a concept used to improve the efficiency of updating the user interface in web applications, especially in JavaScript frameworks like React. It acts as a lightweight copy of the real DOM, allowing changes to be made quickly without directly modifying the actual DOM each time. So say I have developed a particular website in React, which will update every single time, which will have a button. And every time I click on this button, the count will keep on increasing. If I click on it one time, it will give 1, 2, 3, it will keep on increasing. Now, if you look at both of these websites, this is the initial look of the website. And this is after clicking it one time. If you compare both of these web pages side by side, you can see that the only thing that has changed is this particular 0, which became 1. And the only thing that will change is this particular 0. This will keep on changing. Nothing else will change. The button will still be there. The paragraph will still be there. Just this particular thing will change. Now, if only this particular span element is changing, why do I need to render this button? Why do I need to render this whole paragraph? Why do I need to re-render the whole web page? That is the concept of virtual DOM. It develops a temporary lightweight copy of your actual DOM when you try to compile and when you try to run the particular React file, and it compares both the pages. What has changed? And whatever has changed, it only renders those components. Wherever the change is detected, only those components are rendered instead of the whole web page, which saves a lot of time. Although this is a very small application, so here it won't make a lot of difference. But if it's a complicated, huge application, then yes, it does make a huge impact. So this is your original DOM and this is your virtual DOM. This is your DOM. This is your DOM tree structure. Say you change 2 elements here. So now this whole tree doesn't need to be rendered because there's these two changed. So React compares both of them, the original and the virtual, and sees that only these elements have been changed. Hence, they are also updated in the original DOM. Moving on to our next question. What is state management in React? Now, state management involves controlling the flow and handling of data within your app to ensure the UI responds correctly to user inputs and data changes. Now, there are multiple types of state management in React. There is component state, props drilling, context API, and state management libraries. Component state is like your use state and use effect. Props drilling is an important and interesting concept here. Here's my React file. Now, if I have a particular message, props drilling is basically passing the message from the parent to the child. Like say if I have a message here, hello from the parent component. Now this is the parent component. We're gonna send this to our middle component. It's gonna take a prop as the message. This will be our parent element. And then when you come to the middle component, you will take that message as your prop, arrow function, a div element. And now here, this will be my middle component. Here I'll call my child component and pass the message as a prop to my child component as well. Moving on to the child component. Again, we'll be taking the message as a prompt. And here we'll finally be showing the message. Child component, our message, which we brought all the way from the parent component, will be displayed in this particular child component. That is props drilling. Now in case of huge applications, this becomes a problem, because if it's a smaller application like the one that I just showed you right now, it's easier to keep track of the ones that you're using. But if you create a complicated application, then you'll not always be able to remember the order of your components or the layout of or the structure of your whole website, and it can lead to confusion and a whole bunch of chaos. That's why you have context API, which is useful for global state management. Next, we have state management libraries like Redux and all, which is used for complicated applications. Moving on, what are some of the commonly used hooks in React? Now in React, there are a lot of hooks like useState, useRef, useReducer, useContext. But in this particular question, we'll be looking at the three most commonly used React hooks. That is useState, which is used for creating variables that can change over time. useEffect, that is used to handle the side effects in a component. Then useContext, which is used to access data from a context in your component. For a better understanding, let's consider an example. All right, now let's look at the code for better understanding. Let me open my React file. I've already created a React file right here. Now, if you don't know, all you have to do is go to command prompt and then write npx create React app and then give any name to your app and press enter. Your React application will be created. Going back to my VS Code, let me remove this middle component and things like that. So for this example, let's just create a timer, a clock timer. All right, so other than React, we'll need to import useState and useEffect. useContext, I'll show you in another example. For this, let's just look at useState and useEffect. I need to create my state here, time and set time. I'm gonna keep it 0. Then let's call useEffect and create an interval, set interval set time function. The previous times is value will be increased by 1 every 1 second. Then then this function is gonna return. When it's gonna return, it will clear this interval, and in here let me create an h2 perhaps, time, all right. Now if I start my application, okay, we haven't called it in the app yet. Clock time. Now you can see it's getting increased on its own. Now that is how you use useEffect and useState. For managing the state, we're using useState, and for creating and clearing the interval, we are using useEffect. Now let's move on to understanding how to use useContext. So for this, let's first create our context. For that, let me just create a file called as message context, which will have the message to provide it to the rest of the code, because this is global. So whatever message I'm going to put here, it can be accessed by every single file out there inside this particular React project. So I need to import create context here, and then this will be message provider, which will have this prompt. But before that, I'll need to create the context. So that will be message context, which will be create context. Next, this will be the provider. Let me put my message here, which is, hey, this is create context. All right, now in the return part, message context dot provider, the value will be this particular message, and this prompt will come here. Now we can create another file, display message, which will display this content from the message context. Now in this particular module, I'm gonna import use context, and then here I am going to import my message, which will be from message context. And the next line, we will display the message. Now let's go to our app.js and add it here. Here I'll import message provider because I need it here, and then inside our display, or rather display message. Now let me run it on the browser. I'll have to re-render it. All right, here is your message, and this is the create context. That is, we are importing it from the create context. Not just display message, you can even create other applications. We still have a clock timer. Here also we can try and bring our use context, and display it somewhere here. Now if I put the clock timer here as well, this is the create context. It's inside the context file also. That is what I'm talking about. It creates a global context which can be accessed from any file. All right, so let me stop this and let's move on to our next question. That is, explain the component lifecycle in React. Now, there in the component lifecycle in React refers to the sequence of events that happens to a component from its creation, that is mounting, to its removal, unmounting. Now let's look at these processes one by one. To start with, let's compare it side by side with an analogy so that it will be easier for you to understand. So to start with, you consider a person who just woke up. So that is known as the constructor function, that is the initialization, waking up from the bed. Next, you have the dressing up part, which is known as rendering, that is getting ready to interact with the real world. Dressing up, drinking coffee, or whatever you do before you get ready to meet the world is called as render. And this, if you compare it with your UI UX design, when you design your website so that it's ready to interact with the users, that is called as render. Then you have the particular part where you go to work, you attend phone calls, or you do your job, you code, whatever you do. That is called component did mount. And this whole process comes under mounting. Moving on. Next, throughout the whole day, the person can keep on deciding if they need to change their clothes or if they need to do something new. That is called as should component update. Should a new feature be added? Should a re-rendering take place? And if the person does decide to change a new dress, or does decide to do something new, then you have to re-render the whole thing again. Again, rendering comes in. Next, the person can think about whatever they did throughout the whole day, which is component did update, that yes, the update did happen. This whole process is called as updating. Moving on, we have the last phase, which is when this person goes to bed. You are done with your everyday activities and you're preparing to shut down the whole process, shut down your whole body and your mind. That is, component will unmount, and that is inside unmounting. So, to summarize, we have mounting, updating, and unmounting. Mounting is when the component is created and inserted into the DOM, the person waking up, getting dressed, interacting with the world. Updating is when the component's state or props change. Should the change happen? If the change did happen, then render it, and then the change happened, so commit the changes. And lastly, we have unmounting, that is shutting down the whole process. Moving on to our next question, which is what is context API and how is it different from props? So we just looked at how we can create a global state using use context, which is part of context API. And props, we saw that in props drilling, as in how we were passing the component from the parent till the child, which passed through the middle, parent, middle, and child, and how difficult it was. And then how we solved it with use context, which was a global context, and this is part of context API. Let's look at how these are different in a tabular format. The context API is a feature in React that allows you to share state and data across components without having to pass props down manually at every level. It helps manage global state and avoids prop drilling, where you have to pass data through many layers of components. Now let's look at the table. So the purpose of props is to pass data from the parent to its child components. And the purpose of a context API is to share a global state across multiple components. Data passing in props is explicitly passed down through component hierarchy. In context API, you can access it directly in any component. You just have to use the use context and you can access it from any component inside the same React file. Next, reusability. Components are tightly coupled to their parents, and if you have to call a child of one particular parent, then if you're calling that child from another file, say a parent number 2, then you'll have to call the parent as well to get that child file, because there might be prompts that are passing from the parent to the child. Next, in case of context API, components can be reused as many number of times as you want to, and they're independent, meaning when you're importing one context API, there are no additional prompts or anything that you need to take care of. It's much more clean. Depth of component tree. Props can lead to prop drilling in deeply nested structure, whereas in case of context API, it can avoid props drilling completely. Any child can access the context directly. Setup complexity. Props is simple and straightforward, whereas context API requires setup of providers and consumer components. Context API does take a little bit of time to set up, but once you get the hang of it, context API can save you a lot of time and keep your code modular and very, very neat. Moving on to our next question. How can you optimize performance within a React application? Now, React itself tries a lot with features like virtual DOM and a lot of other libraries. React itself can optimize performance a lot, but there are other things that you can take care of. Like, we have pure component built-in performance optimization. This is like the virtual DOM I talked about, only rendering the particular components that have been changed. That is the built-in performance optimization, like filtering out only the ones that needs to be updated. Next, you have load paths when it's needed. That is code splitting or lazy loading that we talked about when we looked at the Pinterest example. Next, you have optimizing context usage. That is whatever data that you're sharing, make sure to only share the data, only share the particular parts that you need. Like when we looked at the case of GraphQL in that API, we were fetching only the parts that we needed. So when you're sharing, don't share the whole file, just share the particular things that they need. For example, in an API, if you're sharing, don't share the whole body of the API. If they only need the name of the file or the title of the particular item, just share the title. Next, we have remember calculations and functions, that is memoization, like the caching and cookies and session data, temporary data, so that it doesn't have to be loaded over and over again. Next, you have reduce component re-renders, control when components update. Don't go around updating the same component over and over again. You can add new features, but don't go around and keep on updating the components. Moving on to our next question, that is, what do you understand by a higher order component in React? Now, a higher order component is a function that takes a component as an argument and returns a new component. HOCs are a pattern for reusing component logic. Now, to understand this better, let's consider an analogy. So say whenever you go on websites, when you click on a particular link in any particular website, you'll see that it starts loading, like the way it is loading right here. So it will take some time for it to load before the website is finally loaded. So this particular whole part, which when it was loading, that is done by a higher order component. How? Let's look at a code. Now you can see this particular code where you can return a new component and add your logic here. Now, if you consider the loading code in this particular format, you can see that with loading is loading and props is the pre-existing state. So now here you have the loading function if isLoading is true. That is, if your website can detect that it is loading, that means isLoading is true, then you will display the loading scene. Else, you can go into the main component, which is the wrapped component. And then you can go around and show the main component right here. That is HOC. So if isLoading is true, it will keep on loading, and the moment isLoading becomes false, your website will be displayed. And this isLoading function is called as a higher order function, which is used within another function. So in summary, a higher order function is any function that you use inside of a function. Like this loading thing is very important inside this website, because when you're transitioning from one web page to another web page, you need some kind of connector there. So that's why you need to fill in with a function. So that's why it's called as a higher order component. Moving on, we have our next question. How do you handle forms in React? So when you think about any forms, Google Forms or any kind of forms, there are three main important things that you need to keep in mind. That is, managing the form inputs, how what kind of inputs your user is going to send to you. Then capturing the user inputs. There should be a field so that your users are able to input their values, whatever values they need to put in the form. Then you need to be able to store this user input. Then you need to be able to respond. When they give you the data, store the data, then you manipulate the data, then you have to respond to it as well. Let's understand this with our code. So let's move on to the code part here. Let's create a new form here. I will need to import useState in this particular form. Alright, I will have input value and set input value as my useState, which is, I'm just gonna set it to 0 right now. Then I'm gonna need two functions, which is handle change which will set the input value as e.target. If you have worked with JavaScript, you'll know this one. Then you have handle submit, which will obviously handle the form once it's been submitted. Let's do e.prevent default, which will prevent the default submission behavior. We'll put form has been submitted and here's your data. Let's just put the value of input value here. Now inside of this function, div function, let me just put form, which will have on submit, you will call handle submit, and inside of this I'll create a label for input. Input type is text, name and value and ID, let it be. Value will be input value. On change, handle change function will be called. That's the label one. And then let's create a submit button. Submit. This is how you handle forms. Now this is for taking single input. You are creating a label in here. So you're taking an input inside the label, and the value is input.value, which will take the value from the user. So we're fulfilling the three main criteria with this particular code. The first part where we're taking the input from the user. Second part, we're processing this with the handle change. And when the user clicks on submit, we are handling the submit part as well. But this is for single input. There's just one input field right here. What if there are multiple input fields? So for that, inside the handle change function, so here in the useState itself, you'll have to change everything. Instead of one particular element, you will have to change it to form data and set form data. And here it will be, say, if I have name and email, I'll leave space. So instead of this, we're gonna have to change a lot of things. Like right here, we'll have to put const name and the value, and this will be e.target, and we'll have to set the form data as the already existing form data plus the name, which will be set to your value. And then we'll have to update the form data here as well. Okay, don't get confused by the name here. This is just, I can change it to something else also. I think the name will be, you will get confused with this name. That's not it. It's just if any item, say if this is name or this is email, then that its value will be updated in the form data. Now the already existing form data, this will also be appended. So here we need, this is the name field. This will be form data dot name, and we'll need another label. This will become the name label. This will become the email. Type will be email, and handle change. And that is how you handle multiple inputs. All right. So now you know how to manage the form inputs, how to create user forms, and how to respond to form submissions regardless of a single field or multiple fields. Let's move on to our next question. What is server-side rendering and how is it beneficial? Now there is two types of rendering. One is client-side rendering, that is rendering the information after my local server has fetched the data from the original server. And the next one is server-sided rendering, which is already delivering to my local system a rendered web page. That is in this original server itself, the file will be rendered and then it will be delivered to my particular local machine. Server-side rendering is a technique where a web page is rendered on the server before it is sent to the user's browser. Instead of sending a blank HTML file with JavaScript code that builds on the page of the server on the client, the server generates the HTML with content already included and sends it to the browser. That is already, everything is defined, everything is rendered, and then that particular data comes to your local machine. That is SSR or server-side rendering. Now, an amazing example of this is your Times of India website. If you go to that website and you try to scroll down, you'll see that all the data is preloaded for you. How is that happening? That is called as server-side rendering, because all the data that you're looking in front of you, that is already rendered. It's not rendering after it reaches you. It has already been rendered and then it reaches you. This significantly reduces your page loading time. Then another example of client-side rendering is your social media apps like Instagram. Although Instagram does uses CSR and SSR together, the first interface that you see of Instagram is server-side rendering. But once you start scrolling, it's client-side rendering, because based on your user activity, you will be suggested that kind of reels which you want to watch at that moment. So that is client-side rendering. Now the benefits are that it has a faster initial load. Since the HTML is pre-rendered on the server itself, the browser can display the content quickly, improving the perceived load time for the users. Next, better search engine optimization. Since when it is listed down on search engines like Google and all, if it is already rendered for you, then the search engines can look for certain keywords inside the website. Now, since it is already rendered, it is already there on the website. Hence, it is easier for the search engines to locate certain keywords. Search engines can easily index the content of server rendered pages because they don't need to execute JavaScript to see the content because it's already there. Next, improved performance. Since most of the rendering is done on the server, client don't need to do as much work to render the page, which is helpful for users on slower or less powerful devices. Reduced interaction time. With SSR, users can interact with the content more quickly because they don't have to wait for the JavaScript to fully load before seeing anything. Moving on to the last question we have for React. What do you understand by Redux in React? In React, components manage their own internal state, but as an application grows, managing shared state between multiple components can become complex. This is where Redux helps by providing a single global state that any component can access. This comes under state management libraries that we discussed in the previous questions. For understanding Redux, we have to do the whole code. So let's get into that. All right. Let me open my code editor. Here it is. Before starting, we need to install a couple of things. We have to install the Redux library. So let's do that. While it gets installed, let me just tell you quickly what a Redux actually is. So I am sure you must have heard of this deadlock situation where one resource waits for another resource. So Redux is exactly something like that. It tries to solve that issue. So consider this analogy that there are a lot of chefs working in a particular kitchen. Now, they all have separate ingredients. They all have separate knives and forks to cut vegetables and do things like that. Now, if one particular chef requires a particular knife and it is with another chef, they have to wait for this first chef to finish using that knife so that they can get it. And sometimes there is a chance that this knife might get lost, and this other chef who was waiting for the knife, they might never get the knife at all. So that is why we need Redux, so that it can centralize all the resources at one particular place so that every other component can access it. Now, in case of Redux, Redux collects all these resources and puts it in a common particular store, say a particular place which is called as the store. So let's create our store which will be called as counter reducer. Now, React has this particular feature where it collects all the resources and puts it in a common warehouse. And that warehouse or that particular store is being guarded by a manager. There's a manager for the store who makes sure what kind of resources to give, when to give. So that is this counterreducer.js file. Next, you need to create the main file where the warehouse where it will be stored. So let's create that. That is our store file, store.js. That is called a store in Redux. Now we'll have to import a couple of things like configure store we need. Next we need counter reducer, which we just created. Counter reducer. Next, if somebody tries to access your store, let's configure that. Let's just put out the resources there. Let's just define who is the manager of the store. And that is counter reducer. Export default store, and that's it. Now we need to create an action. Now, action creators are like when a particular, coming back to our warehouse example, and our manager is standing in front of the warehouse managing everything, and then somebody has to access a particular resource inside the store. Now, for accessing that, they need to create a particular kind of slip or maybe a paper in which everything is written that we're gonna make a website with this example, in which there'll be two buttons, an increment button and a decrement button. So if you click on the increment button, the value should increase. And if you click on decrement, the value should decrease. So that is our action that, okay, I'm going to give the action that increment and the value. There'll be two parameters. So that is what the action is, the paper which you give to the manager that this is the action I need to perform. So we'll need to create that action.js file, inside which, like I said, in our website, we'll just be creating two methods, that is increment and decrement. So I'll create increment, which will have a certain value. Like I said, the type of the action, what I need to perform, and the resource that I'll be giving. Okay, this is my resource, you do whatever you want to do with this. So when I give the resource with the type action, I want the type will automatically become, when it's written increment in my action, in my paper, when I give the paper to the manager, it's written in increment. That means the type of the action I'm requesting for an increment type action, and the payload is basically what is contained inside your action, the value that you're giving, that is payload. And the payload is this value that I will be specifying in this particular function. Same I have to make for decrement as well. Decrement. Okay. Next, we can move on to the app.js file where we'll be creating use selector and use dispatcher. Let me just write that first. Use selector and use dispatch. We also need increment and decrement one from our actions. Now, use selector and use dispatcher, the simplest example that you can understand will be, say, if you consider the example of Amazon's web page. If you say if I create an e-commerce website of my own, then I'll have a particular JSON file in which all the items that I want to display on my website will be stored, right? So retrieving that data from my JSON file and showing it on the website is done by useSelector. Now, when my user interacts with my e-commerce website, when my user click on add to cart or remove from cart, that kind of request, that the request that the user is sending, is managed by useDispatch. Moving on. I hope that made the difference clear between both of them. Now, we need to create a function called as count here, which will be used with useSelector. It will have a already existing state.count. Okay. Then the dispatcher will come, which is useDispatch. Counter with Redux. Here we'll display our count. Below this we'll have our two buttons. This will be the increment button, and we'll have an decrement button as well. So whenever you click on this, we'll call the value, the parameter which we have defined, this increment with the value. This particular value is 1. We'll be dispatching that, okay, a user has requested for something. I told you dispatcher is whenever the user requests for something. So when the user clicks on the button, we'll dispatch immediately with the value 1. This is not supposed to come here, this is supposed to come here. And we will have to do the same thing for decrement as well. Now this is not enough. We are left with one last step, which is the connection point. We have to connect Redux with our application. For that, you will have to go to the index.js, there it is. And here, instead of this React strict mode, we need to replace it with provider store. We have our own store. Let's close that. I'll remove this. Store, we will have to import. Alright, that is done. Alright, we didn't do one very important thing here. If you go back, we haven't set the state yet. So let's do that. So the initial state, we're gonna keep the count for the initial state as 0. And counter reducer, when it's called, the by default state value will go, and it will have the initial state, and there will be an action. Alright, moving on, we'll insert a switch case which will define what to do based on the actions type. So there can be the case of increment. Whenever that happens, you have to return the already existing state, but the count will increase by 1. The same thing for okay, don't worry, VS Code. Happy? All right. -1 will happen. Then there will be a default case where you'll simply return the state and do nothing more. Now, if you look at this particular code, you can see our initial state is here. Click on increment. That was all there to know about Redux. Moving on to the next component, that is Node.js. In this particular module, we'll be covering 10 questions. So before we start with this, let me just walk you through how to create a server using Node.js. Let's call HTTP. We don't need that. we need a port. Then we need to create the server where we'll be taking request and response. Rest dot writing something, we'll be sending the status code as 200, it's fine. Then we'll be setting the content type as plain text. Then we can end the response. Then we can listen our server on the port that you have selected. Let's log that. Server listening on port. Then if I try to run this code, and if I open my localhost 3000, it is listening on this particular port. Now, Node.js and Express.js are very closely related with each other. So if we have to convert the same code to Express.js, we'll have to change a lot of things, starting with this. You'll have to first call Express, and for this you'll have to install Express as well. I've already installed, so I'm not going to install it again. And you will have to require it here. Then you need app, where we'll be calling Express. Port remains the same. Instead of creating the server here, we'll have to do app.get, getting the root page, request, response. Let's send something. We can remove this and it will be app.listen instead of server.listen. If I try to run the same code again. Okay, let's try to run that, and it's again hello world. Those are some of the changes between a Node and an Express module. Although in the course we have broken down Node and Express into two different modules, most of the times both of them are very closely related. So let's go back to our PPT. And let's start with our first question. That is, explain asynchronous and non-blocking program. Starting with asynchronous. Asynchronous programming allows your code to start a task and move on to the next one without waiting for the previous task to finish. Now, let's take an example or take an analogy for you to understand this better. Say that you went to a coffee shop to order coffee. Now, there's a long queue in front of the coffee shop. Now, because the queue is so big, you're just standing at the end, you're waiting for your coffee to arrive. Now, while you're waiting, you're doing other tasks as well. That is called asynchronous. So that's how asynchronous process works. Asynchronous process is when you're trying to get something done, when a process is happening in the background, but it doesn't interfere with the other processes as well. So here in this particular analogy, while you're waiting to get to the coffee shop so that you can order your coffee while waiting in a line, you're doing other tasks as well. Like maybe you're reading news on your mobile phone or you're scrolling through reels, but you're doing other tasks as well. That means other tasks are also getting done. That is asynchronous programming. Next, we have non-blocking. Now, non-blocking programming refers to the way Node.js handles tasks without stopping or blocking the execution of other codes. Let's consider another analogy. Say you called your friend to talk to her. Now, she didn't pick up the call. Or maybe she did pick up, but she said she has some work to do, so you couldn't talk a lot. So you just hung up on her and then you started doing something else, like maybe jumping on a trampoline. That is non-blocking. When you try to do a particular program, when you try to do a particular task and it doesn't interfere with your other tasks. That task keeps on happening in the background, but it doesn't interfere with other tasks. Now, this might sound similar to asynchronous, but it's not. Here, there's a difference. Let's see what that is. Asynchronous refers to the timing of the tasks. Tasks run independently and notify when they're done. But in case of non-blocking, it refers to the behavior of the code, ensuring that no task waits or holds up the system. If it's not a non-blocking task, it's like when you're using your mobile phone and some app is updating or installing, that's non-blocking. That updation thing is happening in the background. It's not interfering with the other tasks that you're doing in your mobile phone. That is called as non-blocking. Now, asynchronous is the timing, that whenever it's happening, when it's done, it Node.js notifies you that, okay, this is done, you can go and check on it. Moving on, we have our next question. What is the event loop in Node.js? Now, this is again related to both asynchronous and non-blocking. Let's see how. Event loop in Node.js is a mechanism that handles asynchronous operations. It allows Node.js to perform non-blocking I/O operations even though JavaScript is single-threaded. How? Let's consider another analogy. Let's just say you are a chef and you're going to cook something. Now, there are obviously certain steps that you need to follow. So you're starting with boiling water. Now, obviously, it's not like when the water is boiling, you just stand there and watch the water getting boiled. When the water is boiling, you can go around and do other tasks, like maybe chopping the vegetables. By the time the water is boiled, you can come back and do whatever you are going to do with the water. But in Node.js, there is another particular, you can say your assistant, who checks if when a particular task is done. So in our analogy, this assistant is going to check if the water is getting boiled, if it's done, if this particular process number 1 is done. Then she'll check, oh, is the process number 2 of chopping vegetables, is that done? And if she sees that a particular process is done, she will notify the main chef that this particular process is completed, so that the chef can come back and do whatever it was supposed to do with the water. So event looping is basically a particular cycle, and this little arrow over here is the assistant, and this is the task that need to be get done, and these are the tasks that is happening in the background. So it keeps on checking that, okay, water is getting boiled, is it done? The vegetables are getting chopped, is it done? Making pasta, is it done? Adding vegetables, is it done? And it is a whole loop. It keeps on looping over and over again, and as soon as the task is done, it is thrown out of the event loop. That is how event looping works in Node.js. Moving on, we have our next question. What is middleware in Express.js? Middleware in Express.js is a function that has access to the request object, response object, and the next middleware function in the applicant's request-response cycle. Let's consider an analogy. So, from the server, from whatever website you've hosted, you get a request to your particular website that, okay, this client is requesting this particular server, a particular thing, and then you send a response to it. Middleware now comes in between this, so that when the server is sending a request, it first passes through the middleware before it reaches you. And when you send the response, it again goes to the middleware and then it goes to the response. Middleware coming in the middle. Now, this middleware can take care of a lot of things, like logging in. That is when a request comes in. It can log what kind of data the user is asking for. It can pass the data, that is what kind of format, if it's being sent in some other format, it can convert it to JSON format or whatever format you want it to be. And it can authenticate the user as well from the request, that if this particular user is to be given access to certain parts of the code, certain parts of the website. Also, this middleware it's not just that there's one single middleware. There can be different middlewares for different processes. Like there can be a middleware for checking if the request is valid. There can be a middleware which logs the request. There can be a middleware which changes the format of the data. That is how middlewares work in Express.js. Before we move on to the next question, I want to show you how to write and how asynchronous and non-blocking programs work. So let's move on to that. Let me open my code editor here. So for this code, let's just create a file. I'm going to call it example.txt. Hello, this is the file that we created. In here, Let's call the file reading library. We're gonna read example.txt, add the character, then there can either be an error or some data. If there is an error, then we have to console.log that something went wrong, and we'll have to show the error, and we'll just simply return. Otherwise, we'll read the contents of the file, which will be the data. Now, asynchronous programming is basically, it happens in the background like we talked about. So regardless of this program being executed or not, this code, this line will be shown first. Let's try running it. That is how asynchronous works. It works in the background, and regardless of what's happening, it's always in the background. I hope that clears asynchronous. Moving on. Let's move on to our next question. How does Node.js handle child threads? Now, what are child threads? Again, we talked about asynchronous and all, right? A process happening in the background. Who takes care of it? That is child threads. The processes that work along with your main thread and which takes care of the other processes that are happening in the background, like installing or updating applications in the background while you work on your phone. These are done by the child threads, which are not hindering with the main activity. Main activity is whatever. If you open Instagram and you're scrolling through Instagram, that is your main activity. So your main thread is that. But there might be background processes going on. Maybe you're installing an application from Play Store. So that's happening in the background. That is being managed by a child thread. That is what child thread means. Let's look at the technical definition. Node.js handles child threads by using worker threads for parallel processing. Parallel processing is working in the background. That is both the processes are going parallelly, but the child process is not hindering with the main process. And child processes for creating independent processes. The event loop and non-blocking I/O handles most asynchronous tasks. Like I said, the assistant keeps on rotating. Is the boiling the water? Is it done? Chopping the vegetables? Is it done? It keeps on checking, and when it's done, it sends a message to Node.js. Okay, that this process is done. We can terminate it, ensuring that Node.js remains efficient and fast. Now, there are three types of child threads that you can find in Node.js. One is the event loop and non-blocking I/O, which we just saw. Next, we have worker threads and child processes. Let's look at how this is happening. Starting with worker threads. Again, let's go back to our chef example. You are the chef, you're boiling water. Now, what if you have some other important task to do? Other than chopping vegetables, maybe there's something else which requires your full attention and you cannot come back to checking these smaller kind of tasks like chopping vegetables or boiling the water. So what do? You call an assistant who will take care of this boiling water part for you. Now, while your assistant is taking care of these tasks, you can move on and do the rest of the important tasks like cooking your main dish. And now this assistant is your worker thread in Node.js who is taking care of the smaller activities that require your attention, but you need to focus on higher or more important things. So you make your assistant do it for you. That's worker threads. Moving on, if you look at the technical definition, worker threads allow you to create threads that can run JavaScript code independently, that is, separate from the main event loop. Next, we have child processes. Now, what if your chef, coming back to our chef analogy, what if your chef gets a particular dish which is very hard to create? So even for your chef, it is difficult to create that particular dish. So your chef needs help from some other professional chef. So what do? You call the other professional chef from another kitchen or from another restaurant who will help you cooking this particular dish. That is a child process. Now, child processes run alongside the main program to handle specific tasks which have a higher priority as compared to the smaller tasks that your threads were handling. Threads, obviously, processes are more powerful than threads. So if there is a process which is much more important, say the best example I can think of as a process is this installation. For threads, you can consider when you open WhatsApp and you're downloading a particular image that your friend sent to you. When you're opening that, that's a worker thread. But if an installation is happening in the background, that's a process. So to handle that process, because that thing in itself is a huge factor, the app getting installed. So you can't handle it with a thread. You need a process to handle it. That is where child processes comes in, who take care of the installations. These threads can work in parallel, that is in the background, allowing the main thread to keep doing its job without waiting for these helper threads to finish. Now, both of these are processes, right? The child process is also a process, and your main process is also a process. So they communicate with IPC, that is called as inter-process communication. The communication between threads is called as IPC. This was there in SQL databases. So if you look at the main difference between the two, that is that child processes, because they are processes, they have their own memory space. But threads, they don't have their own memory space. They exist with your main process itself. Moving on to our next question. What are streams in Node.js? Now, streams are like a huge flow of data, which you can parse or change its format or extract the meaningful data out of from. You consider stream as a huge flow of maybe a waterfall or something. Let's look at the technical definition. In Node.js, streams are a way to handle reading or writing data continuously, piece by piece, rather than all at once. They are particularly useful for dealing with large amounts of data or data that is being received over time, like files, network requests, or any process that requires data to be processed gradually. Now, there are multiple types of streams in Node.js. We have readable, writable, duplex, and transform. Readable streams, as the name suggests, are used to read data. Examples include reading files from the file system or receiving data from an HTTP request. Writable is again used to write data. Duplex is a special kind of streams which can be used for both readable and writable streams. They can read and write data independently. Next are transform streams. This is a special type of duplex stream itself which can modify or transform the data that is being read or written. Let's take an example to understand all of this better. We've already worked with this file library. Let's call it again. We also need stream this time, and we're gonna call transform and duplex from stream. Let's create a readable stream first. Create read stream. Let's take our example.txt file, which is already there. That character encoding thing. Now let's call on to transform. Now this is the last one, transform. Let's create a transform. Now this particular class initializes a transform stream that is going to transform the data as it is being read from our example.txt file. Let's see how that happens. We need to call the function transform, which is going to take chunk, which is the data encoding. Encoding we're not going to use in this example. Then the callback, a function that is called when processing is complete. Then we have callback. This function will be called once our whole transformation is done. All right. What we're going to do in this transform is we're going to change every single word inside that example.txt to uppercase. So chunk, the data, if you want to, let's just modify it to, if you want to, you can also call it as data, whatever suits you. Let's convert that to uppercase. Then callback null. Null will indicate that no error has occurred, and we'll call uppercase. So this function is called, it will return this particular line. There is some error showing here. Oh, alright, we're supposed to put this here. Okay, that's all you need to know for the readable stream. Now let's just create a writable stream. fs.create write stream. We'll have to create a new file. Let's call it result.txt. Now this result.txt file, if it's existing, then its data will be overwritten. Or if it doesn't exist, then this result.txt file will be created for you. So we need to create a duplex stream as well for this. Let's call new duplex. Continue. Let's move on to the right. We need chunk encoding, which we're not going to touch again. And then there's the callback file, which will be called once your whole code has finished executing. When the write file is called, it will write processing the data, and you can change it to string. Let's just push this data into that file. Next, finally we'll just call the callback function, and that will be it. Now we'll have to pipe the data from the readable stream into the duplex stream. That is, we'll be creating a readable stream and we'll be piping it with the duplex stream. We'll also be piping it with transform stream. We're just combining everything together. Then we also have writable stream, and then when this is finished, we'll log to the console all the data process is completed. Let's run this code. There's an unhandled error somewhere. Let's go and try to find out. Resume. Okay, we hadn't used the readable stream actually. We can't use it this way. We'll have to change this a little. These two are fine. For creating the transform stream, the old method doesn't work. You need a new method, which is new transform, and then you'll have to call transform stream separately. Transform, which will be a function. Now this will have your chunk encoding and callback, inside of which we'll paste this. Now let's run it. Maybe we need to add the read here. Alright, we need to convert this to string first, and only then can we do to uppercase, I suppose. Alright, that were the mistakes that we created, that we did. And hello, this is the file that we created. There's a D. And I believe our result, there it is. In our result file, you can see that everything has been converted to uppercase. So let's move on to our next question, which is, what is callback hell and how can we fix it? Now, callback hell is a situation in programming, especially in JavaScript, where multiple nested callbacks, that is multiple functions, which is, we looked at props drilling in React, right, where one prompt was being sent to another, like it was taken from the parent, then it went to the middle, then it went to the child. So all of these were nested inside one another. Similarly, in Node.js also, in JavaScript also, you can write the code in which there's one function, inside of which there's another middle function, inside of which there's another function. So if this kind of situation happens where there are multiple functions nested inside a single function, that is called as callback hell. Now, this makes the code difficult to read, understand, and maintain. Now, the callback hell in programming will look something like this. There is a function at the top, like this do something function, which gets result 1. That result 1 is being used by another function, which is inside the first function. Result of the second function is used by the third, then the third by the fourth, and it just keeps on going. Now, this can end up looking like a pyramid or a staircase, a never-ending pyramid. It is also called as the pyramid of doom. It's that difficult. Now, to fix callback hell issue, instead of writing this very messy, chaotic, right now there is not a lot of things inside the functions. That's why it seems at least organized. But if you put some data inside of these functions, like if you actually make these functions do something, this will look very chaotic and very messed up. Now, to fix this, you have a number of methods. You can start by using promises. Promises is instead of using a lot of functions, you can put then and catch. That way you can see the error handling also becomes a lot more easier, because there's just one error handling catch. There's just one error handling catch line. Everything else is if this particular line happens, then you can do this. If it doesn't work, it will directly go to the catch statement, which keeps your code much more clean and organized. Promises help to flatten the nested callbacks and make the code more readable. Or you can use async and await. Now, this is more like your synchronous task only, because if you are using await, then it will wait for the whatever you're waiting the resources for. If you look at this particular example, this result 2 is awaiting for result 1, which is awaiting for another function. Now, this does make the code a little bit more cleaner, and this can convert async into sync, because sync is when one function is waiting for another function to be executed first, so that the first function can be executed. Now, with using await inside async, you can convert an async code into a sync code, which will make the code much more linear and modular again. Or you can just modularize the code. Now, instead of writing the functions this way, one inside the other, you can instead put it this way, where you can break them all apart and keep them modular, which will break the code into smaller modular functions, making it again more organized and reduce the nesting. And this can also help reduce the nesting. Moving on to our next question, how do promises improve callback handling? Now, this is what we discussed in the previous question. How do promises help? We've already seen that promises allow you to chain asynchronous operations using .then, making the code more linear and readable. Now, this can also convert your async code into a sync code, because after one function happens, then another function happens, then another function happens. This is joined by that .then, that parenthesis. And this is how the code looks like that we already saw. There's a main function. After this function happens, another function happens with the first function's result. So it keeps the code much more cleaner and linear. It improves the readability of the code. Error handling is much more better, because there's just one error statement which handles all of their errors. And whatever the error is, it will be mentioned here as well. So you'll know where the error is coming from. And then there is your flexibility. Your code is much more modular and flexible. So moving on, we have our next question. What is the purpose of package.json? Package.json serves as the central configuration file that defines important information about the project. Important information like the project dependency management, the project's configuration. There. Here you can find a lot of things. Your version, the metadata, the dependencies, the scripts, and everything is included in the package.json file. So let's move on with our next question. What is the difference between process.nextTick and setImmediately? Now, process.nextTick is used when you need to run your code immediately after the current operation with higher priority input-output tasks. SetImmediate is used when you want to defer the execution of a code until the IO operation are complete and you can wait for the next event loop cycle. Process.nextTick next tick is used when you have a high priority task, but right now a task is being executed. So process.next tick will wait for that particular event loop to finish, and just immediately after the first one is finished, process.next tick will be executed. But as for set immediate, it is executed after everything is done. It's just like, okay, I'll wait for everything to get over and then I'll execute my task. That is set immediate. Let's look at the difference in the tabular form. Then we'll look at the code as well. So process.nextTick runs after the current code finishes, but before the next event loop cycle. That is, if a process is happening right now, process.nextTick will wait for that process to be executed, and then only it will get executed. Set immediate runs in the next cycle of the event loop after the input operation. After everything is completed, it will go and it will run. Process.nextTick has a higher priority than set immediate. Process.nextTick is used for the tasks that need to run immediately, but after the current operation is finished. For set immediate, it can wait till the end of the event loop cycle. Process.nextTick is high priority. Set immediate is lower priority. Let's look at the codes. Alright. So if I put a start log here and I call process.nextTick, has been called. And if I just call set immediate and I log it here, set immediate has been called, and then I can end the process. So if I run this code, it starts and it ends first, and then next tick has been called, and then set immediate has been called. Now the interesting part here is, even if I put set immediate on top of this next tick, it will come at the end, because it waits for the event loop to get finished completely and only then does it get executed. That is the clear difference. Now let's move on to our next question, which is, how can you handle errors in Node.js? Now, to handle errors in Node.js, it's important to ensure that your application runs smoothly and can recover from unexpected issues, which is why handling your errors is very crucial in any application. There are multiple methods to handle the errors. You can try the try and catch block. You can try asynchronous callbacks, that is .then and catch. And then you can even go for global error handling methodologies. These are the methods that are available. How can you use them? You can use them together. You can use try and catch with async and await, so that whenever if any particular await function doesn't work, you can put it inside a try and catch block to exactly figure out which one didn't work for you. You can handle promises. You always need to add rejections when you're using promises. You always need to add a rejection as well, so that if your promise gets rejected, what happens then? That is again another part of error handling. Then you should stop using process.exit, because it exits from your process abruptly. So if anything goes wrong, you will not know because your process exited abruptly. Then you can use error objects to better handle the errors in Node.js. Moving on to our next module, that is Express.js. In this module, we'll be looking at 10 questions. So let's start with our first question. That is, how do you handle routing in Express.js? Routing in Express.js is handled using the router class, which allows you to define routes for your application. Now, to understand this, let me just open my VS Code here for you. Now, the difference that routing makes for you is, let me just create a Express file. We already know about app.get and app.listen. But what if I was trying to make a particular application, say about, and I am going to need the request and the response here in this application. Okay. Now the problem arises. Now this is fine if I have an about section like this. If I make a follow page like this, and if I can make multiple pages like this. But what if I have to go deep into one particular page? What if I have to go into the about us and then the header section inside about us, or maybe the footer section in the about us, or maybe the achievements section in the about us? Then this code, although all of this is about, looks very hectic. Now to solve this issue, we have the router. How to use the router? So instead of creating it this way, you can create a new module itself, about.js, and here, let me again call my express, and here I'll create a about router, which I can call express.router. And now instead of doing this app, I can just write about router. So this can get the achievement section. Let me just shorten that. And this can also look out for the header section. This can also look out for the footer section. It will take care of every single request that you need to take care of. And then in the main code, we don't have to write all of this. We have to export this also, and we don't need to listen this here. So I'll just remove the port as well, and we don't need app. Export. We'll just export that router, and we'll import the about router, and in the main file at the top we'll put for about. We can use the about router, and that's how easy, and that's making your code even more modular and much more readable. That is where routing comes in for Express. Moving on to our next question, that is, what are the differences between request.params, that is parameters, request.theQuery, and the request.body? Let's look at them one by one. In Express.js, request.params, request.query, and request.body are used to access data sent in an HTTP request. How? Let's look at the differences. For request.parameters, you focus on the heading part, the parameter, the route. It is request.parameter used to get the route. For the user ID and all, you can get from the route itself. That is where request.parameter comes in. For request.query, that is when you're accessing the sorting parameter, like you're sorting it according to the age in this particular example. That is where you need the query. When you're applying certain kinds of query, that is sort in this particular case. And then there's a body where you're trying to access the body, which the data that is coming from your API request. That is where you need to use the request.body. Now, I hope that was clear to you. Moving on, what are middleware functions in Express and how do they work? We already looked at middleware in Node.js, but in Express.js also, middlewares are there. Like I said in the beginning itself, Node.js and Express.js are closely knit together, so you cannot understand Node.js without understanding Express.js as well. So in Express also, middleware functions are functions that have access to the request object, the response object, and the next middleware function in the application's request response cycle. So there are three types of middlewares in Express. That is the application level middleware, the middleware that can access everything inside the code, router level middleware, which is only specified to specific routers, like we looked at the about router, that is router level. There can be other routers, the body router, and different sections. For different sections of your website, you can have different router level. Then there is error handling, which is for handling the errors. If you look at an example, let's start with application middleware, to call this again. Now, if I add an app.use here, take the request, response, and move on to the next function. Here, where I'm trying to use the data from the response is called as the application level middleware. Now, if I have to use for router level, I can just put the about us router and I can put it to use here. Here also I can do the same thing, request response next. That is router level. Then you have error handling. Error is when if you get any errors, you can log that as well. That is called as error handling. That is error handling middleware. Moving on to our next question. How can you handle errors in Express.js applications? You can use error handling middleware that we just saw. Then there is 404 handling and custom error handling. Let's look at them one by one as well. We already looked at this, right? Now, if I send in the response, if I keep the status as 404, which is not found, I can just send request does not exist, or not request, I'll write requested service does not exist. That is your handling 404 errors. Or you can even have custom errors where you can create for custom errors you'll have to create classes, which is not found error. Let's say if you have to again do a not found error, you'll have to extend an already existing class, and obviously there's a constructor. There'll be a message which will be shown in the beginning, super.inherit message, and the status, not the stack, the status will be 404 not found, and when your user goes to a specific route which is non-existent route or something, if that happens, then you can create a new instance of this class, not found error. Before we'll have to add it with the next. This route does not exist. And that is how you create your own custom errors. Moving on, what is the role of body parsers in Express and how do you use them? Body parsers play a crucial role in any Node or Express application, but the importance is that body parsers make it easier to work with data sent from the client to the server. For example, if a client sends JSON data in a post request, the body parser will convert that JSON string into a JavaScript object so you can access the values directly. Let's consider an example for better understanding. For this, you'll have to install body parser. Okay. So that's installed. Let's go back. Now I need to use body parser in my code. Require body parser. All right. Let's use the body parser now. Extended true. Okay. Now, if you make a post request from any particular, say if you have a form, and if they submit the form, then there'll be a post request. You'll get request and response. You can log on to your requests body using your body parser, and you can just send the message received. You can use this when you create forms in JavaScript. You have certain input fields like the name input field, the password input field, the email input field. So if you need to collect data from those particular fields, you use body parser. And then once you submit the form, all that data, you can collect it with the help of body parsers. Moving on to our next question. How do you implement authentication and authorization in Express.js? Now, Authentication is the process of verifying the identity of the user, and authorization is determining what actions the authenticated user is allowed to perform. So authentication comes first, where you try to authenticate the user that who are you, and next is authorization, where you provide like if you're accessing a website or there's a library management system. Now there can be two types of users. One is the manager of the library, who will keep on updating or adding new books to the library's data management system. So the authorization for both the manager and any regular customer visiting the website to purchase a book will be different. The person who is there to purchase can only see the books listed out, but the manager can add books, remove books, edit the description, and is provided a lot more access. That is the authorization part. And then there's the authentication, which verifies your identity to be able to log into the system. Let's look at an example so that you have a better idea of how to implement authentication and authorization in your Express.js code. Let's create a new file, auth.js. I'll call my Express first. Then we need the JSON web tokens. All right. Express dot JSON, which allows us to read the JSON files. Then there will be a secret key which will be used to validate the user. So for now, I'm just gonna keep it like this. Then there will be, let's just create a dummy user, a temporary dummy user, which will only exist in my particular system right now. So let's keep the ID as 1, and we need a user name. Let's keep it as user name itself. Then we need the password. Keep it as pass123. The by default password you should not be using. Next, when the user makes a post request, that is when the user submits, or maybe when the user logins or tries to log in, that is when we are supposed to perform our authorization. That is when we are supposed to perform our authentication. So we're going to check with the username and the password, which we're going to take from the request's body. We didn't add body parser here. If we're accessing the body, we need body parser. All right. Okay. So we're going to check if the username that we got from here is equals to users' username, that is from this user's this username. And we also need to do the same for password, user.password. If that is true, then we can create a new token, a special token which is created to recognize the user. The user comes back to visit the website again, then this special token will be used to identify the user so that we don't have to authenticate the user every single time. So that's why we need the JSON web tokens to identify the user. If this does happen, then we can create a temporary user ID. Repeat, then we'll create a user ID which will be taking from the user's user ID itself. Then we'll need to give the secret key, which is specific for then we'll need to give the secret key. Then we'll have to put the expires in, as in how long before this session expires. That's 1 hour. We'll give 1 hour here. Then we'll just return this token, and that's it. However, if it doesn't match, then we'll just give the status 401. 401 is the unauthorized status, HTTP status. So we'll send that. We'll keep the status as that, and then we'll send invalid credentials or maybe wrong credentials. Invalid or wrong credentials. That is how we authenticate. Now let's authorize the user. Let's create an authenticate token for this. Request.response, and we also need next. Now let's create the authorization part. For that, we need request, response, and next. First, let's try to check if the user has the token that we talked about. So for that, you will need to take the token. If the token is there, then that will be returned here. So that will be present in the header of the request. So we're going to fetch that from the header of the request. It will be under authorization. If it's not there, then we'll return the status, which is 403. That is forbidden. Then we'll send token is required. However, if the token does exist, then we'll verify it with the JSON web tokens. We'll see if the token, the secret key, and everything else, error and decoded part. So if there is any kind of error, you can return res.status as 403. Again, unauthorized. You can say it's invalid token. However, there is no such issue. If the user is valid, then with the help of decoded, we can take the value from the new request, whatever the new updates which will be made by the user, we can take that value and add to the existing database for that particular user. And then we can move on to next. Now, when we try to do app.get, when we try to use app.get for the main root page, we have to write the specify the authorization token here as well. And that's it for the authorization and authentication with Express.js. Alright, so moving on, we have our next question, that is, what is CORS or CORS and how do you handle it in an Express application? So CORS is cross-origin request sharing. Now before understanding cross-origin request sharing, you need to understand what is a cross-origin request. So imagine you and your friends go to a particular restaurant and then the waiter comes over there with a menu. You scan through the whole menu and you don't find anything you like. So what you ask the waiter, you tell him to bring you a particular dish which is not available in this restaurant, but it is available in some another restaurant. This is called as making a cross-origin request. That is, requesting for a particular resource not from your website, not in the website or not in the restaurant in which you are currently sitting, but from a website, but from a different website, a different restaurant. That is making a cross-origin request. So in technical terms, when one website tries to get data or information from a different website or another website, that's called as making a cross-origin request. Now, naturally, the waiter will not allow you to do that because they don't know that if the other resource that you're bringing from another website or the other food item that you're ordering from this website, if it's safe or not. So obviously the waiter will not allow that. Now that is where cross-origin request sharing comes in. It's like a special permission slip which you can give to the waiter, because by default websites have this thing where they won't allow you to bring resources from another website because they don't know if it's safe or not. So you give them this special ticket, this cross-origin request sharing ticket, which compels the waiter to let you take food from the other website and give it to you, which compels the waiter to take the food from another restaurant and give it to you. That is exactly what cross-origin request does. Cross-origin resource sharing is a security mechanism implemented by web browsers that allows servers to specify who can access their resources over the web. Cores work by using HTTP headers to define which origins are permitted to make requests to the servers. It can control what kind of what resources can be allocated to other websites which are requesting for a particular resource, and it also can allow what kind of resources you are letting go from your website to another website. Moving on to the next question, how do you manage sessions in Express.js? Now, session management is commonly handled using middleware like Express Session. This middleware helps store session data on the server, ensuring that each user has their own session with a unique identifier. Now, why is managing session important? Session is like, let's take an analogy. Imagine you're visiting a mall, a shopping mall every single day, and there's a guard standing outside the shopping mall. Now, every single day you go and the guard have to check everything. What's your name? What's your ID? What's the password for going in? Everything. Now, if you have a particular slip with you, then you can just give it to the guard, which the guard only gave you in the first place. Then the guard can verify your identity with the help of that slip. Hence, you don't have to verify your identity, authenticate yourself every single time you visit there. Even in our authentication and authorization, when we made it in Express.js in the previous question, you saw how we were creating a token, which the user could use the next time they visited our website. This is the reason why we need to manage the session, so that we don't have to authenticate the user every single time they visit our website. Now, how to implement this in code? Let me create another application. Session.js. Let's bring Express first. Then we need session, which is Express Session. Next, app.use session. Let's create a session. Now, while creating a session, you need to give the secret, which can be anything. So you can say your secret key. You have to resave it. Resaving prevents if a session already exists, that is, if a token already exists for a particular user, you don't have to change the token and replace it with a new token, because the token is already there. So you don't have to change that token. You only need to update certain changes. Like if my session is there on Amazon, if I visit Amazon and I add, when I first visited the website, I didn't add anything to my cart. Second time I added some things to the cart. So they don't have to create my profile all over again. They just have to update certain things, like the items which I added to the cart. That is what resave is. So we don't have to resave it every single time. So let's give it false. Save uninitialized. This is if a user is new to the to your website, then it forces that user's session to be saved. Next, you have cookie, which is how long should this session last. So let's give the max age as, say, a minute. Yeah, a minute. All right, that's all you need to know. And then you go into your app.get. Now here, if request.session.views, then you can increase the views, and then you can send the message that the number of views that your particular user had was request.session.views. Else, request.session.views you can keep as 1, because by default there will always be 1. And this is a request, and then you can send welcome to the website. That's all. That is how you create sessions in Express.js. Let's move on to our next question. That is, how do you create a RESTful API using Express? Now, A RESTful API, or a representational state transfer API, is a way for different software applications to communicate with each other over the internet using a set of rules. Let's create a RESTful API. I'm just going to call it api.js, our express file. And now we can create a simple RESTful API about maybe, let's say, a to-do list. So in a to-do list, there can be multiple things like adding to-dos, creating new to-dos, deleting, updating. So we can create an API for that. Let me just give you a basic about how to do it, then you can do it yourself. If I'll just show you how to create to-dos, you can do the updating and deletion part. So we first need to create an empty array of tokens, and we also need to allow this JSON. Next, once the app.post request comes, that is when they click on the OK button or maybe the add to do button, there will be a request and response. We need body parser. And here we can create a new to do which will be request.body, and we'll have to push it to do's, it's not token. Into this to do's, we'll have to push this new to do that we just created. Then we'll set the status as 201, which means it's successfully created. And then we'll send a JSON file which will be the to do that you have just created or you have just inserted. Then when on the displaying page, on the root page, we will need to show all the to-dos. That will be this to-dos. Then we can create, and if we click on a particular to-do, then you can maybe add its ID to access a certain to-do, because every to-do will have its own IDs. So we will have to first find it. To-dos dot find, let's take t.id should be equals to %, request.parameter, because we're taking it from this, so that's why we're using parameter, and the ID part in the parameter. If to do is not there, then we have to return the status as res.status 404 not found, and we will send the message as to do not found. However, if it is there, then we will send the JSON of whatever to do we did found. In the similar way, you can create updation and deletion as well, but this is how you create RESTful APIs. Now, moving on to our next question, that is, how do you connect an Express application to a database such as MongoDB? Again, we'll have to go back to the code. I will call this as Mongo Node Express. Now keep in mind that I'm using MongoDB Atlas. So if you're trying to use this, you need to have an account created in MongoDB Atlas. In Atlas itself, you will have to create your own clusters. From there, you will get a particular code which you can use to connect with your VS Code. There it is, Atlas. Now let's try to connect it. All you need is you need to install Mongoose. Then you have to use it here. Mongoose is require Mongoose. Then you can directly add mongoose.connect. And whatever ID you get from your MongoDB Atlas, you'll have to copy that and paste it here. Then we'll be giving a promise. it will be Atlas connected. If some error happens, we'll have to give a catch as well. We'll have to give a catch statement as well, which will be something went wrong. Something is already wrong. Oh, the semicolons. Okay. Now if you try to run this, mongo.js, right. So let me go to my MongoDB project overview here. I'll quickly connect it. Let me add my IP, and we need it for VS Code. You can copy it from there. Now if I try running this code, MongoDB Atlas connected. And that is how you connect your Express code with MongoDB Atlas. On that note, let's move on to our last module, that is MongoDB, in which we'll be covering 10 questions. So let's start with our first question. That will be, what are the main differences between MongoDB and relational databases? To understand the difference better, let's consider a scenario where you have to store the books and their authors in both the databases. So in case of MongoDB, you can store everything all at once in a single document itself. You can store the title, the author, the name, and the genre, whichever genre it prefers to, and the rating, and everything you can store in one single place. But in case of relational database, you'll have to create a different table for the books to start with, and then another table for the authors, and then you'll have to use some kind of, and then you'll have to use foreign key. Maybe you can use the author ID, it's already here. You can link these author IDs together using foreign keys to group the data. When you're trying to derive results or when you're trying to do some certain kind of transactions, you'll need to use these foreign keys to get the desired output. So in technical terms, in relational database, data is split into tables with strict relationships. These relationships must be managed carefully, and changes to the structure can require significant updates. As for MongoDB, everything is stored together in one document, making it flexible and easy to work with. New fields can be added easily and deleted easily without needing to change the entire database structure. So even if you have to add a particular new book to the already existing book database, and even if it doesn't match your existing, say you're adding a new book which doesn't match with the already existing structure, you don't have to worry about anything in MongoDB. There is no predefined structure, maybe the title, name and all, but other than that there is no predefined structure. You can add it any way you want to. But in relational database, everything should be strict and perfect and structured. Now there are pros and cons to this. Let's look at them. As for MongoDB, there is no fixed structure. Fields can vary depending on the document. For relational database, everything is fixed. We talked about that. For MongoDB, when we talk about data relationships, it can store related documents together in one single document. But in relational database, you have to create separate tables and link them together with foreign keys. As for transactions, MongoDB supports basic transactions, but it's not as strong as your relational database. Relational database supports strongly for transactions, ensuring your data is reliable. MongoDB is best for applications which have varying data and real-time analytics and big data. Relational database is for applications needing complex queries and structured data like banking system. Moving on, we have our next question, that is, what is the difference between a document and a collection in MongoDB? Document, we just looked at. This particular thing in whole is a document, or let's simplify it. A name, age, city, where there is a key and a value. A key, value. All of this grouped together is known as a document. Now, there will be multiple documents like this in MongoDB. If all of these documents are grouped together, that is called as a collection, which is a grouping of documents. In technical terms, a single entry in a MongoDB collection represented in BSIN or binary JSON format, it consists of field key value pairs where fields are strings and values can be of various types. Collection is the grouping of documents. It acts as a container for documents similar to tables in relational databases. Moving on to our next question, what is a replica set and how does it work? Now consider you have a library or a main server in which there's a main bookshelf which has your most important list of books. Now that you keep backup bookshelves also. Now this is a little crazy to have, but still just consider it. This is some crazy person's house where they also have backup servers because this bookshelf is very essential for this person. So they keep backup servers as well in which the copies of all these books are present. Now, if something were to happen to your main book server, it will be replaced by one of your backup servers, right? That's what backup servers are for. And then your backup server will be replaced by another copy of backup servers. This is how replica set works. A replica set is a group of MongoDB servers that work together to ensure data redundancy and high availability. It consists of one primary node and one or more secondary node. In our case, this is the primary node and these are the secondary nodes which are there as a backup. That replicate the primary nodes' data so that the data in the primary server is safe and secure, and also if something were to happen, the data will be secured. Now, there are two types of replica sets. Now, there are two main operations, which is the read operation and the write operation. For read operations, by default, the data is updated first in the primary server and then the data is copied to the secondary servers. So by default, the data is read from the primary server, but you can configure the changes according to whatever is your requirement. For write operations, there are multiple choices you have. You can either only allow write operations for the primary server, or you can allow it for the backup servers as well. That's again up to how you want it to be. Moving on, we have our next question. How does MongoDB handle data consistency? Now, there are multiple ways. There is eventual consistency. After a write operation happens, the data might not immediately be consistent across all the nodes, but it will become consistent over time. Then we have write consistency, where write concerns determine the level of acknowledgement required from the database after a write operation. Like I said before, does the primary server require acknowledgement or do the other servers require an acknowledgement? That is write consistency. This one, W1, W majority and W0. If it's W1, that means only the primary server needs to acknowledge. If it's W majority, then the majority of the secondary servers need to acknowledge. If it's W0, no acknowledgement is required. Next, there is read consistency, which allows to specify the level of consistency required for read operations. Again, there is three types: local, majority, available. Local is when you have to read it from the primary server. Majority is when, because the data is getting updated, the first place it will be updated is the primary server. That is local. But if you want to, you can go with the majority also, where you will be reading the data from the majority of the secondary nodes which are updated or which are not updated. That depends on whatever choice you want. Last, we have available. Available is reading the data from any node that is available, even if it might not be updated. Just take the value from there. Maybe some old values there which anybody haven't touched in ages. Then the data, there is a very high chance that it might not have been modified. So you can just take it from any node. Moving on, replica sets that we just talked about, creating a primary node and creating secondary nodes. Then there is transactions, which supports multi-document transactions, meaning a group of operations can be executed in a way that it ensures that either all the operations take place or none of them happens. Moving on, what are indexes in MongoDB and why are they important? Indexes in MongoDB work by storing a small portion of the data in a way that makes it quicker to search through. Indexes are similar to the index at the front of a book, which allows you to quickly locate a topic without having to read every pages. Now, the benefits is faster query performance. If you know what you're looking for, and IDs are always unique. So if you know the specific thing that you're looking for, and if you have the ID for it, obviously your query performance, when your API will come to look for what you need, it directly knows where to go. Faster performance. Efficient sorting. Again, if you already have an ID, you don't need to sort through everything. This is like if you go to a hotel room and you know your friend is in one of the rooms. If you have your friend's room number, then you don't have to go on knocking on every single door. Hey, is my friend here? Hey, is my friend here? You'll know which room to go to. So obviously, sorting is much more efficient. Then improved filtering. Again, you don't have to go knocking on every single door. You know which room belongs to your friend, so you directly go there, and your filtering also becomes very easy. Moving on to our next question, explain the concept of aggregation in MongoDB. Now, aggregation is taking the data that is already stored in your database, performing calculations or manipulations on it, and then producing a meaningful output out of it. In MongoDB, aggregation operation allows you to transform and analyze the data in the MongoDB collection. There will be a lot of data in your collection. You have to take that data and make meaningful output out of it so that you can utilize the data. For example, if there is a list of all the marks you got in a class or in college, then that will not make a lot of sense, right? But if you calculate the average of the marks, then you can that becomes a meaningful data. You can show that, okay, the class average for maths in my class is this much. This is the percentage that the majority of the class got. So you perform the average operation on that particular data. That is called as aggregation of data. So in MongoDB, if I go back to my Atlas here, go to browse collections. In Atlas, I'm doing this, and if I scroll down, this is the data that I have. So fruits, there's banana, apple, and mango, quantity, item, quantity, and price. So if you scroll up, you can go to the aggregation part. Now, let's create a new stage. Let me expand that. So say if I were to calculate the price, which is say greater than 3. Yeah, everything is greater than 3. So if I perform greater than 10, there is just one item, mango. Moving on, let's use group this time, and let's take the ID from the items' ID, and let's just try to create total, where we will calculate the total quantity, the sum of all the accumulated values. All right, so these are the total of all the items that are there. It's going to group them together with their IDs, which is the name, and then it's going to aggregate, it's going to group the data, it's going to check for the quantity, and it's giving me my result. There are total 16 apples, 20 bananas, and 56 mangoes in my database. And there are a lot of other operations you can perform here, like count, densify, fill, etc., etc. Moving on, we have our next question, that is, how does sharding work in MongoDB? Now, before understanding sharding, you need to understand what is a shard. Now, shard is any piece, an essential piece of your database. Consider this example so that you can understand it better. Imagine you have a database which contains 1 million user profiles. Now, the problem here is that if multiple servers tries to access my database at the same time, then my database might not work as it was supposed to be, or it might explode, or anything might happen. So to ensure that this fire thing doesn't happen, we can create multiple smaller servers. Instead of storing all the 1 million user profiles in one huge database, we can divide it into smaller pieces of data. We can divide it into smaller databases. How? Look at this. There are 4 shards, and we can distribute the user profiles equally among them. Like from 1 to 250,000, we can keep in shard 1. In shard 2, 250,000 to 5 lakh, and moving on, so and so till 1 million, we can distribute them equally in the shards. This way, even if multiple servers try to access my particular database, it will not crash. Moving on. Now, who decides how to distribute the data? How should the user profiles be distributed? Who decides that? That is decided with the help of shard key. So in summary, sharding in MongoDB is a method used to distribute data across multiple servers or shards to ensure that the database can handle large data sets and high traffic. It's usually for load balancing. Moving on to our next question. What are the different types of queries you can perform in MongoDB? Let's look at them one by one. Let me open my code. Okay. So there are a lot of queries that you can perform in MongoDB, but I'll just quickly show you whichever they are. Say you already have this particular MongoDB client code. I've already connected it and I've kept it waiting here. Now let's write our queries one by one. For calculating the result, you can have the result query. Await the collection dot find the field with any value to array. That is how you use the result query. Then you have the range query when you need a particular range. That way, say collection.find, I need a specific, my field is quantity. If I want my quantity to be, say, greater than 15, that is a range. I can convert that to array and then print out the result. Then you have logical query. Again, let me just copy that. This time we're not finding, this time we're updating. Logical queries is updating. Say if I have to update one item, say mango, I have the new value is that I want to change the quantity to 20. That is the update 1. This is the update. If I have to update, there is update many as well. Let me show you that as well. Update many is there as well, where you can add multiple fields here instead of one. That is update many. And in update many, if you can even say that in item mango, instead of setting it, I can increase all the values by 15. That is update many. Then you can delete as well. This will be delete one, and delete many is also there. Where say I have to delete the ones with the quantity that is less than 15. Okay. Then I can even aggregate it here itself that we just saw in our Atlas's interface. I can even do that here. Aggregate with anything I want to specify. I can do with group like we done. Where the ID we specified as item and the total was we declared we were trying to find the sum from the quantity of the application of the database items. You can convert that to array and then you can print the result. Those are all the queries that you can find in MongoDB. Moving on to our next question, that is, what is the role of the object ID in MongoDB documents? Now, object ID is the by default ID that you can get. Let me rewrote that. All right. So if I were to insert a document here, I will get a by default, I'll get an ID. This is called as the object ID. Now, what is that object ID? So in the object ID, the first 4-byte timestamp represents the creation time. The 5-byte random value that comes after the 4-byte, it's unique to the machine and the process when it was created. Then the 3-byte, which is the ending 3 bytes, is the incrementing counter, which is initialized to a random value. Moving on to our last question. How do you handle transactions in MongoDB? Now, handling a transaction is basically starting a session. You have to create a whole session to handle any particular transaction in MongoDB. So you start by starting a session. That is, you can click on client.start session. Then you have starting a transaction, that is session.start transaction. Then you can perform your operations, whatever you like, insert one, update one, or abort the transaction completely. Then you have committing the transaction, where you use session.commit transaction. And then there is session.end session, where you completely close off the session completely. And that's it for the video. Thank you so much for watching.